Let's talk about factoring trinomials when a is greater than 1 or the leading coefficient is greater than 1. In the previous video, we practiced factoring trinomials where the leading coefficient was equal to 1 or when a was equal to 1, but in this video, we're going to try factoring these trinomials where a is anything but 1. And to keep things consistent, we're going to use the same strategy that we used in the previous video for factoring for this one as well. Alright, so let's jump right into it. For number 1, we have the trinomial 2x squared plus 11x plus 5. So I'm going to go ahead and take a look at this 2, which is the leading coefficient, and the only factors of 2 I can think of are 2 and 1. Next, we're going to go ahead and look at the constant, which is this 5, and think about the factors of it. Well, 5 is a prime number, so there's only 1 and 5, and our goal is to see if we can get a combination of 11 in the middle. So we have to try a couple things here, but if you try going across and multiply, that would be 2 times 5, that's 10x, plus 1x, that's going to be 11x, so that does work. You know you don't need to go diagonal because that would be 2x and 5x if you multiplied, and those combine to get 7x. So if you go ahead and combine this way, that would be 10x, that would be 1x, those would be your pairs. All right, now if we go ahead and set up our binomials, then we're going to go ahead and see that there's 4 locations to put things. The 2x is going to go in the beginning here, and the plus 5 is actually going to go over here. Keep that in mind that when you went and said that this 2 and this 5 combined, we said in the last video that you should pair them this way. And then for the last 2 spots here, we're going to put a 1x in this location, and then we'll put a plus 1 in this one over here. So when you go ahead and pair this 1 with this 1, those get paired on the inners, and this would be the factored form for this trinomial. For number 2, we have 5y squared plus 19y plus 12. And so a is equal to 5 here, and that's a prime number, so we know it's going to be 5 and 1. Looking at the 12, there's a few options. There's 1 and 12, 2 and 6, 3 and 4. And my recommendation is always start with the numbers or the factors closer to each other first. And if they don't work, then work your way out, okay? If we try going diagonal, this would be 20y and 3y. That doesn't equal 19y. However, if you go across here, that would be 15y and 4y. 15y plus 4y is 19y. So to get this 19y here, we will have to multiply these two as our outers and these two as our inners, or vice versa, okay? Now we're going to open up our binomials and place these 4 things in the right location. So I'm going to go ahead and put the 5y here and 1y in this location. And this 5 pairs with the 3, so go ahead and make sure you put the plus 3 on the outers so that those pair just like this. And then we're going to go ahead and put the plus 4 in the first binomial so that this 1y times 4 is going to be paired up right over in this location. All right. For number 3, let's see what we got here. So we have 7x squared plus 53x plus 28. So for 7x squared, a is 7, which is a prime number, which is nice because we know it's 7 and 1. Now for 28, there's a few options, right? There's 1 and 28, 2 and 14, 4 and 7. But 4 and 7 are the closest ones together, so I'm going to start with those ones. If we try going across, that would be 28x and 7x. Combining those, we get not 53, right? We get 35. But if we try going diagonal, this would be 49x plus 4x, and 49x plus 4x is 53x, so that's what we're looking for, right? So if we go diagonal, this gets us what we're looking for. So those are going to be the outers and the inners paired together. So we'll go ahead and set up our 2 binomials. We'll go ahead and write our 7x over here and our 1x in this location. Now this is going to be the outers, so that 7 is going to pair with a 7. That's located right here, and then that means that the 4 has to go in this location right here for the inners, right? So the outers are paired like this, and the inners are paired like this. For number 4, we have 5y squared plus 18y plus 9. So our a value is 5, so that's nice because it's prime again, so 5 and 1. For 9, what do we have? There's 1 and 9 and 3 and 3. Again, I'm going to start with the numbers closer to each other first, and let's try this, right? Now, since the 3's both match, it doesn't matter if we go across or diagonal, it'll be the same. But if we go across, that's 15 and 3, which does make 18, which we're happy about. Again, you can see this is 15 and 3, so it doesn't really matter which way you go. So to get this 18y, I'm just going to go across for the outers and across for the inners, and that was the hard part. The easier part here is just going ahead and setting up our binomials. I'm going to put a 5y and a 1y. And because they're both just plus 3, we can just fill these both in because it doesn't matter which one goes in which spot. They're the same number. So these are the outers, these are the inners. We took care of both pairs and they multiply out. For number 5, let's see, we have this 2x squared plus 3x minus 9. So again, 2 is prime, which is nice because we don't have to think of other factors. Now we have this negative 9 at the end, so we know that we have to have a positive and a negative. So again, I know 3 times 3 is 9, so I'm going to use a 3 and a negative 3. Okay, and now if we go across here, this would be 6 and this would be negative 3. So what's 6 minus 3? That is positive 3, which is what we're looking for, right? If you accidentally went this way, which is okay, you would have got a negative 6 and positive 3, and that would equal a negative 3x, but we're looking for a positive 3x. So we know that we're going to try to go across here. So positive 6, negative 3 combined to make this positive 3x that we're looking for. Okay, so we can go ahead and set up our binomials. We know we're going to have 2x located here and 1x located here. The 2x has to pair with the plus 3, and the 1x has to pair with the minus 3. So again, for the outers here, this is going to be located right in this spot, and for the inners here, that's in this spot. For number 6, we have 3y squared minus 8y plus 4, and so 3 is a prime number for a, so 3 and 1. And now for 4, what do we got? It could be 1 and 4 or 2 and 2. Now I'm going to go with a negative 2 and a negative 2, and I'll tell you why. Keep in mind that we have a positive 4 here. However, we have a negative 8. So whenever that happens, we need 2 negative numbers to add to the middle, but 2 negatives still multiply to get positive 4. Okay. Now it doesn't matter if you go diagonal or cross because the negative 2's are the same, but 3 times negative 2 is negative 6. 1 times negative 2 is negative 2. Negative 6 plus negative 2 is this negative 8. So this does work out if you go straight across. Again, diagonal is the same just because the negative 2's match. And so we can go ahead and set up these binomials. And we're going to have 3y and 1y. And because they're both negative 2's or minus 2's, then it doesn't really matter how much you think about where to put those. So this pair technically is out here, and then this pair is in here. All right, that's the factored form for this trinomial. For number 7, we have 4x squared minus 15x minus 25. So this 4, this is composite, right? So it could be 4 and 1 or 2 and 2. Let's start with 2 and 2 and see what happens. If it doesn't work, we'll just switch it up. This is a negative 25, so it could be 1 and 25 or 5 and 5. Now I'm going to stay true to my strategy of choosing the numbers closer to each other. Because it's a negative 25, one of these has to be negative. Now if we try going across here, notice what's going to happen. This would be negative 10, and this would be positive 10, which cancels out to make 0x. That's not what we want. And if you go the other way, that also doesn't work because it's the same thing. So this is not what we're looking for. Instead, we should go ahead and try mixing it up a little bit. So maybe we could try doing something like this where we go ahead with 2 and 2, and we could try something like 25 and 1, right? And one of them's got to be negative, so I'm just going to make one of them negative here. This would be 50 and negative 2, which makes 48. That's not what we want. And if you go diagonal, it's the same thing. So that doesn't work either. So my next strategy is, okay, we tried changing the factors of 25. Let's try changing the factors of 4. And let's go back to using the 5 and negative 5 for 25. Now let's see here. This would be negative 20, and this would be positive 5. So what's negative 20 plus 5? That is negative 15. So that's actually what we're looking for. So I wanted to show a couple examples too, where if you don't get it on the first try, it's not a big deal. You just have to try some more possibilities. Okay. So if we're going to go ahead and write this out, we can go ahead and see that we're going to have these two binomials, and we will go ahead and write the 4x and the 1x in these locations. The 4 is paired with a negative 5, and the 1 is paired with a positive 5. So for the outers here, you can notice here, that's right on the outers. And for the 1 and the 5, that's paired up on the inners. For number 8, we have this 6y squared plus 7y minus 49. So 6 is another composite number, so we have to try a few things maybe. But let's start with 3 and 2. And then for this negative 49, I'm thinking 1 and 49 or 7 and 7. But let's see here. I'm going to start with 7 and 7. And I'm going to make one of them negative because we have a negative 49. And let's see if we can pair some stuff up here. So if we go across, that'd be negative 21. and this would be what, positive 14. So negative 21 plus 14 is negative 7, which is close to positive 7. It's the opposite, right? So what happens if we pair the other way? That's going to be positive 21, take away 14, and that does equal this positive 7. So that's going to work better for us because we want a positive 7y in the middle, not a negative 7y. So again, that's the hard part. Easy part now is just filling in the pieces in the right spot. So the 3 represents 3y, the 2 represents 2y. What did the 3 pair with? The 3 paired with a positive 7, and the 2 paired with a negative 7. So again, for the outers here, that's located in this location, and for the inners, that's over here. If you swap the inners and outers, it doesn't matter, so feel free to switch those if it works for you. For number 9, we have 6x squared plus 5x minus 6. So 6 is another composite number, so we have some possibilities, but I'll start with a 3 and a 2. And if we look at this negative 6, that's also 3 and 2, but one of them has to be negative, right? So I'll go with a 3 and a 2, and just throw the negative on one of these, and if it's not right, then we can move the negative in a little bit, no worries. If we go across here, that's negative 9 and positive 4. So what's negative 9 plus 4? Ooh, that's negative 5. So that's close to what we're looking for. So what I'm going to do is I'm just going to go ahead and switch it over. So I'm going to get rid of this 3 being a negative, I'll make it a positive, and let's make this 2 negative instead. So see what happens here. This is going to be positive 9 minus 4, which does equal positive 5. So this is going to be our pairing, 9 minus 4. So don't be afraid to just try the numbers and then switch the negative as needed. And so here are our binomials. We're going to have 3x and 2x, and the 3x is going to be paired with a positive 3, and the 2x is going to be paired with a negative 2. So for our outers, right over here. For our inners, right over here. For number 10, we have 4y squared minus 35y plus 49. So 4 is composite. I'm going to start with 2 and 2 though, and see if that works. This 49, we have to choose 2 negative numbers. So I'm going to choose negative 7 and negative 7 just because of the negative 35 in the middle. If we try going across, that's going to be negative 14 and negative 14, which combines to make negative 28. That's not what we're looking for. Instead of changing the 7s, I feel like changing the 2s to 4 and 1, just because it's less drastic of a change. Changing the 7s to a 49 is a much bigger and smaller number, so I'm going to keep these negative 7s the same. If we go ahead and pair up, this would be negative 28 and negative 7. What's negative 28 plus negative 7? That is negative 35. So that was the right move to make. And if it wasn't, that's okay. We just try again. And what we're going to have for our binomials here, we're going to go ahead and write 4y and 1y. And since they're both minus 7, we don't have to worry too much. We can just write minus 7, minus 7. So the pairing here looks like this and looks like this. All right, on to problem 11. So for 11, we have 6x squared plus 13x minus 28. So 6 is composite. I'm going to start with 3 and 2, and we'll try 6 and 1 if we need to, but these are closer. And then for 28, we have 1 and 28, 2 and 14, 4 and 7. I'm going to stick to my choosing the numbers closer to each other, like 4 and 7. One of them's got to be negative just because it's a negative 28. And so let's see what happens here. If we go across here, that's negative 12. Negative 12 and positive 14 make positive 2. That's not what we're looking for. If we go diagonal, that's going to be 21. 21 minus negative, or 21 minus 8. Oh, that is 13, right? So 21 minus 8 is 13. So diagonal does work if we combine this way. All right, so that's the hard part. And the easy part, again, is just filling in. We know we have 4 spots to fill. We have 3x in one spot, 2x in another spot. That takes care of 2 out of the 4. The 3 pairs with the 7, so that goes on the outside, and the minus 4 goes inside this location here. So nice and easy pairing right over here and right over here. For number 12, we have 8y squared minus 14y minus 15. And so what we're going to do here is we are going to look at this 8 and say, okay, it could be 1 and 8 or 4 and 2. I like trying 4 and 2 first. And then for negative 15, we have 1 and 15 and 5 and 3. But we know 1 has to be negative. So I'm just going to throw it on the 3 for now and see what happens. Okay, don't think too much about where to put the negative. If we try going diagonal, that's going to be negative 12, and this is going to be positive 10. So negative 12 and 10 make negative 2. That's not what we're looking for. This will be positive 20, and this is negative 6. So 20 minus 6 is positive 14, but we want negative 14. So if that ever happens, just go ahead and swap these signs. If you check it again, this will be negative 20 plus 6. That does equal negative 14. So that's what we're looking for. That's good. So negative 20 plus 6. So that was all the hard thinking. Now it's just sticking things in the right locations. So we have 4y, 2y, plug those in there. And 4 gets paired with this minus 5. And 2 gets paired with this plus 3. So outers here, inners here, and we are good to go. Now it's factored. For 13, we have 6x squared plus 29x minus 5. And so for this 6, I'm going to start with a 3 and a 2 as usual. And for this negative 5, that's nice, it's a prime number, so it's got to be 5 and 1. You don't have to think too much about those, but 1 has to be negative, so I'm going to make the 1 negative. If I go across, that's going to be 15, take away 2, that's 13, that's no good. If I go diagonal, that's negative 3 and positive 10, that makes 7, so that's also not good. So we got to scrap this. Now, because 5 was prime, we know we can't change that one, so I'm going to make this a 6 and 1. And let's go ahead and keep the 5 and negative 1. Okay. If we try going across, that's going to be 30, take away 1. Oh, that is 29. So that's what we're looking for. Okay. So 30, take away 1 is 29. So let's see what we got going on here. If we go ahead and write this, this would be 6x and 1x. And the 6 gets paired with a positive 5. And the 1x gets paired with a negative 1. So we go ahead and say that these paired to make the 30x, and these pair to get 1x, negative 1x, and 30 minus 1 was the 29. For number 14, we have 10y squared minus 43y plus 12. So for 10, we have 1 and 10 and 2 and 5. So I'll start with 2 and 5. And then for this positive 12, we have 1 and 12, 2 and 6, 3 and 4. Let's start with 3 and 4 just because they're closer to each other. The negative 43 in the middle dictates that these have to be negative. So go ahead and make sure these are negative, okay, because they still multiply to get positive 12. Now this is going to be negative 6 and negative 20, which makes negative 26. That's no good. If you go diagonal, this is going to be negative 8 and negative 15, which makes negative 23, which is also not what we're looking for. I'm going to stay away from moving the 2 and 5 for now. I'm going to choose to change the 3 and 4 and just see if we can make those a little bit further apart. So that's going to be negative 2 and negative 6. Let's see if that works any better for us. And so that's going to be negative 4 and negative 30. So that's negative 34. This will be negative 10 and negative 12. That's negative 22. So that's also no good. So let's see what we can try next. Maybe we can try doing something like, let's go ahead and change the 10, the factors of 10 to maybe 10 and 1. And for the 12, let's actually try going back to the 3 and the 4. And maybe you'll see why I was thinking this, right? So if we do this, again, we're looking for 43, and I was just noticing that maybe 10 times 4, 10 times negative 4 is negative 40, and this would be negative 3. So combining those, we do get negative 43. So as you get the hang of this, it gets a little bit easier because you start noticing some patterns, right? So I just have a lot of practice with this. So I'm trying to show you some trial and error as well, but sometimes it's a little bit easier to see what it should be once you get the hang of it. So we're gonna have 10y and 1y, and the 10 is gonna pair with the negative 4, and that means the minus 3 has to go right over here. So these got paired appropriately here to get negative 40, and these got paired also to get this negative 3 to make negative 43. Last couple here for 15. Let's see, 15 we have 18x squared plus 37x minus 20. So 18 has a lot more factors. It's 1 and 18, 2 and 9, 3 and 6. I'm going to start with 3 and 6 because they're closer together. For negative 20, we have 1 and 20, 2 and 10, 4 and 5. I'll start with 4 and 5, and one of them has to be negative. So I'll just put it on the 4 for now. Here we get negative 12 and positive 30. That combines to get positive 18, not what we're looking for. Here we have positive 15, take away 24. That's going to be negative, so that can't be 37. So we're going to have to change some things up here. Up to you what you want to try. I'm going to try making this 18, 2, and 9 instead. And let's go ahead and keep the 4 and 5 the same. Try not to change too many things at once. It gets a little confusing. If we go across, that's going to be negative 8 and positive 45. Okay, what's 45 minus 8? Oh, that is 37. So that's what we're looking for. So that's good. So this is going to be 45, take away 8, and that is 37. Cool. So that one worked out well for us on the second try. Sometimes you need more tries, but that one wasn't too bad in this case. So 9x and 2x are going to go there. The 2 has to pair with a minus 4, and the 9 has to pair with a plus 5. So these two paired in this spot here, the outer locations, and these paired on the inners. Last one, number 16, we have this 12y squared plus 41y minus 28. So 12 has 1 and 12, 2 and 6, 3 and 4. I'll start with 3 and 4. This negative 28 has 1 and 28, 2 and 14, 4 and 7. And so we're going to go with 4 and 7 to begin. And I'll just put the negative on the 7 right now just to try it. Okay. This would be positive 12, take away 28. That's going to be a negative number, so that's not positive 41. If I go diagonal, this will be negative 21, positive 16. Those also combine to a negative number, so that can't be right. We can try 6 and 2 maybe, and I'll keep this 4, negative 7 the same for now. If we go across, that's going to be 24, take away 14, that's 10. And this would be 42, negative 42 plus 8, that's still going to be negative, so that's not what we're looking for either. So maybe we can try something else here. Let's maybe keep the 6 and 2 for now, and let's try maybe 14 and 2 for 28. Let's change the factors up. I'll keep the negative in this spot. If we try going across here, think about this. This is going to be a huge number, like 84. 84 take away 4 is 80, no good. This is going to be negative 12 and positive 28. That's also no good, okay? So far it looks like we're stuck a little bit right now, that we're not having any luck. So maybe we can go back and use this 3 and 4, right? We'll try the 3 and 4 and then try it with this 14 and 2 and see if that is any better for us, right? So if we go ahead and multiply this, this would be what? 42 take away 8. 42 take away 8, that's not going to be what we're looking for. It's going to be too small. And if we go diagonal, it's negative 6, and this is 56. So 56 minus 6 is 50. It's kind of close, but not quite. So maybe let's go ahead and try now the 12 and 1, those factors of the 12. And for the 28, I don't know, maybe we can just go back to the 3 and 4 and see what happens with that one. And so if we make one of those negative here, let's go and try this. So this would be 36 take away 4. That's no good. That's 32. This would be negative 48 plus 3. That's negative 45. So that's also not what we're looking for. Let's go ahead and see if maybe we can try keeping this 12 and 1. But maybe instead of these ones, let's go ahead and try that 7 and 4 combination again. So 7 and 4. So you got to really stick with it sometimes. I'm trying to show a little bit more of the process in terms of like, what if you're not having any luck finding what you're looking for. But hopefully you can see, like, I've tried a lot of different things here and you just don't want to give up. And sometimes this will happen. Okay, so just stick with it. This is going to be negative 84 plus 4. That's no good. Over here, 12 times 4, is that 48? It is 48. 48 take away 7 is finally what we're looking for, that 41. So we found it, okay? So this happens once in a while. So just make sure, even if you are frustrated, just keep looking. It is possible that these are not factorable, but on this entire worksheet, everything was factorable. And most cases, if you're asked to factor, it will be factorable. So you got to stick with it, okay? When you write your final binomials here, we worked really hard for this last one, or at least I did. Maybe you did it in a lot less steps, okay? And if you did, fantastic. That's going to be 12y and 1y. The 12 is going to be paired with this plus 4 over here, and the 1 is going to be paired with this minus 7. All right, so if you go ahead and take a look, you can see that these do indeed get paired, and these get paired, and finally we got what we are looking for. And that wraps up this video here on 16 different practice problems on factoring trinomials into two binomials where the leading coefficient, or a, is not equal to 1. So hopefully this strategy is getting a little bit more comfortable for you. And as always, keep up the great work that you're already doing. I know some of this can be a little bit tricky sometimes, but thanks for sticking to the end, and hopefully you're getting a little bit more clarity on how to solve these types of problems. So keep up the great work, and I'll see you in the next one.